Imagine a mysterious object hurtling through our solar system at over 200,000 kilometers per hour. An object not bound to the sun's gravity, not following a closed orbit, but slicing through space on a hyperbolic path. It's called 3I Atlas, and it's only the third interstellar visitor humanity has ever recorded. But this time, it's not just the speed or trajectory raising eyebrows. It's the unsettling theory proposed by Harvard professor Avi Loeb. What if this isn't a natural comet at all, but a spacecraft? While NASA swiftly moved to dismiss such claims, citing data consistent with a typical comet, the public imagination erupted. Well, because Loeb wasn't just some internet theorist. He was the same astrophysicist who previously suggested that Oumuamua, the first known interstellar object, might have been an artificial light sail. And now, here we are again, with another strange visitor, another eyebrow-raising trajectory, and once again, serious questions about what exactly we're witnessing. So what is 3 Atlas really? A cold, ancient rock ejected from a faraway star system, or a probe deliberately passing through key planets in our solar neighborhood. Mars, Venus, and Jupiter NASA says it's all just cosmic coincidence. Loeb says the odds are too small to ignore. Meanwhile, the object itself, nearly 5.6 kilometers across, races through our system, carrying with it the chemical fingerprints of a world beyond our own. The question is no longer whether it's alien or not, but why our brightest minds keep reaching for that explanation. Is it data? Is it doubt? Or is it something far more human? A craving for contact? Or the fear of what that contact might mean? Stay with us, because this story isn't just about one comet. It's about the tension between scientific discipline and human curiosity, between data and doubt, and the moment when a theory becomes too compelling to ignore. The story of 3I Atlas begins not in deep space, but on July 1st, when the Atlas telescope in Chile picked up a faint glimmer, a slow-moving dot against the black canvas of the night sky. But as analysts began plotting its path, alarm bells rang. This wasn't an asteroid drifting through our solar system. It was on a hyperbolic trajectory, indicating a non-returning visitor from beyond. Pre-discovery images confirmed its orbit, and within days it was officially designated the third confirmed interstellar object, hence the name 3I Atlas. As it raced closer to the inner solar system, scientists prepared to observe its structure and behavior using every available tool, from ground-based observatories to the Hubble and James Webb Space Telescopes. What they found was unexpected. Unlike typical solar system comets, which are mostly water-rich, 3I Atlas showed a carbon dioxide to water ratio of nearly 8:1, completely flipping the chemistry found in local comets, where water usually dominates by factors of 10 or more. Even more puzzling was its tail-wide, diffuse, and fan-shaped, not the narrow, well-defined plume seen in most comets. But for planetary scientists, this wasn't necessarily a sign of artificiality. CO2 sublimates at lower temperatures than water ice, meaning that 3I Atlas began outgassing much earlier, possibly creating a broader dispersion of material. This subtle technicality, how ices behave under solar heating, suggests the object likely formed in a much colder environment than our solar system, possibly even in the outer disk of another star, or somewhere in the galactic thick disk, a region sparsely populated and ancient. As it approached the sun, astronomers watched the coma grow and measured the reflected light. Interestingly, the way this light was polarized, how it vibrated in certain directions, differed from known comets. This signature hinted at dust particles of unusual size and shape, adding yet another layer to the mystery. Was it simply natural variability? Or did these anomalies point toward something less accidental? NASA, for its part, remained measured. Officials released a statement emphasizing that while 3I Atlas exhibits some interesting characteristics, all available data suggest it behaves like a natural comet. It's a comet, stated NASA scientist Tom Stetler, bluntly, with some features that differ from solar system objects, but still within the range of natural explanation. So is the case closed? Not quite. Because even when science says one thing, history tells us that extraordinary phenomena often demand more than ordinary answers. But not everyone was convinced. The most provocative challenge to the NASA consensus came from none other than Avi Loeb, the Harvard astrophysicist, who's no stranger to controversy. Loeb didn't outright claim 3I Atlas was an alien spacecraft, but he did present something far more unsettling, a statistical improbability that begged for explanation. According to his calculations, the object's flight path passing near Mars, Venus, and Jupiter had a probability of less than 0.5% if it were truly random. And that's where the cracks begin to form. Because if the odds of this trajectory are so astronomically low, what does that say about the nature of the object itself? Loeb wasn't alleging conspiracy. He was inviting skepticism. His point wasn't to prove alien intent. It was to challenge the scientific community to consider all possibilities, even those that make us uncomfortable. And that's exactly what sparked the viral explosion. Mainstream headlines ran with snippets, like Harvard professor suggests alien craft, while social media debates raged between those who believed NASA was hiding something and those defending the rigor of peer-reviewed data. Beneath the noise, though, a deeper conflict was unfolding, one between narrative and evidence. NASA had the data, spectral analyses, light curves, dust signatures. But Loeb had the questions, the kind that can't be answered by simply measuring gas composition. Why did 3I Atlas show no clear tail in early observations? Why did its activity seem to pulse in ways current comet models can't explain? And why do its chemical fingerprints suggest it formed in a region vastly different from our own cosmic backyard? The answer may lie not in either position alone, but in their tension. NASA's approach is grounded in conservatism. Extraordinary claims require extraordinary evidence. Loeb's approach, rooted in possibility, argues that progress comes from pushing against what we think we know. And here's the twist: both are necessary. Without the open-mindedness to explore the alien hypothesis, we risk missing something extraordinary. But without the discipline to interrogate that hypothesis, with data, we drift into fantasy. 3I Atlas, like its predecessor, Oumuamua, has become more than an object. It's a cultural mirror. It reflects our deepest hopes and fears that we are not alone, or that we might be, and that in the vast silence of space, every anomaly could be a whisper from something watching us. And this isn't happening in isolation. The re-emergence of the UAP debate, the declassification of military sightings, and renewed interest in interstellar surveillance all feed into a broader public shift. People are no longer satisfied with easy dismissals. They want answers. And when traditional institutions offer none beyond probably a comet, theories, no matter how fringe, begin to fill the vacuum. So the question becomes not just what 3I Atlas is, but what it represents. A natural relic from a far-off star system, a cosmic coincidence with unusual chemistry, or a probe, quiet, unannounced, and now leaving our solar system before we could fully understand it. The object itself offers no answers, but the global response, scientific media, and public has revealed something far more profound. Our civilization is hungry for cosmic connection, and perhaps terrified of what it would mean to finally receive one. As 3I Atlas continues its silent journey out of our solar system, leaving behind a trail of frozen gas and speculation, the debate it ignited remains unresolved. And maybe that's the most important takeaway, not the object itself, but the questions it forces us to confront. Because 3I Atlas stands at a crossroads of science, wonder, and narrative. On one hand, it is a rich scientific opportunity, a pristine fragment from another planetary nursery, possibly billions of years older than our Sun, untouched by solar winds or planetary collisions until now. For planetary scientists, this is nothing short of a cosmic time capsule. Studying its structure, chemistry, and behavior gives us access to unaltered materials from the galactic frontier. Its high CO2 content, the wide fan-like tail, the unusual light scattering, all of these speak to a place colder, darker, and older than our own solar system. And while none of these alone prove anything artificial together, they paint a portrait of something profoundly rare. On the other hand, 3I Atlas has captured imaginations far beyond the lab. It's become a symbol of the unknown, the possible, the things we still don't understand. The fact that it came so soon after Oumuamua and followed by the even more textbook-like 2I Borisov only adds to its mystique. It sits right between the extremes, not as anomalous as its cigar-shaped predecessor, not as predictable as its icy sibling. That ambiguity is powerful. It resists easy classification, and in that resistance, it invites inquiry. And in today's world, inquiry itself is controversial. There's a growing divide between institutional caution and public curiosity. Agencies like NASA are expected to provide certainty, but when they offer high confidence of natural origin while refusing to publicly entertain alternatives, they risk appearing dismissive even when their data is sound. Meanwhile, figures like Loeb, who openly explore the fringe of what's possible, are both celebrated and criticized, viewed as either visionary or reckless. But maybe that tension is exactly what we need. Scientific progress doesn't come from avoiding the strange. It comes from confronting it with better tools, sharper questions, and the humility to admit what we don't yet know. After all, the same skepticism that once dismissed meteorites as myths or rejected continental drift now recognizes those ideas as foundational truths. So what might we be rejecting today? Is it really so unthinkable that intelligent life elsewhere might send probes, silent, non-communicative, not meant for contact, but for observation? Would such probes behave like 3I Atlas, moving in ways that are technically natural, yet statistically improbable? And if so, would we even recognize one if we saw it? Perhaps more important than the object itself is our readiness to ask the right questions when it arrives. Because interstellar visitors don't wait for us to figure them out. They pass by. They give us a moment, a window, and then they leave. This time, we caught 3I Atlas in motion. We analyzed its tail, its chemistry, its trajectory. But what if the real impact of this encounter is not in the data, but in the shift of perspective it inspires? That maybe our solar system isn't as quiet as we once thought. That maybe every few years, something foreign drifts through watching or simply wandering. That maybe we are not the ones doing all the observing. In the end, NASA remains firm. 3I Atlas is by all current evidence a natural interstellar comet. Their conclusions are grounded, sober, and supported by data. And yet, Loeb's thought experiment lingers not because it's proven, but because it's possible. That's the power of ideas. They don't need to be facts to change how we think. They only need to be plausible. And in the vast silence of space, even the faintest plausibility can echo like thunder. So what now? 3I Atlas is already fading both from our skies and our headlines. But its legacy isn't gone. It's etched into our collective memory as a moment when science, speculation, and imagination collided. And as we wait for the fourth interstellar visitor, who knows when or how it will appear, we carry with us one lingering question. When the next object arrives, Will we be ready to see it for what it truly is?